Hello there, welcome to this video. Microservices are a popular architectural paradigm that addresses the limitations and drawbacks of legacy applications. To understand the foundation of microservices, we need to take a look at the history and evolution of application design, from monolithic to multi-tier to microservice-based architectures. A straightforward way to build a simple application is to design it as a single piece of code encapsulating data storage and access, business logic, and processes and user interfaces. That used to be the way applications and systems were designed and built in the early days. Soon, however, this all-in-one code model showed its limits when building complex, intricate systems. Since everything is tangled together, it becomes quickly difficult to maintain, evolve, and scale such applications. Software engineers proposed the solution to this complexity problem: the multi-tier architecture, where application components are separated into layers based on technical functions. A common model is the three tiers architecture. It consists of three logical layers. A presentation layer covers all the code and components responsible for the interaction with users through visual interfaces. A logical layer encompasses all the business logic and processes relative to the business functions, and a data layer dealing with storing, accessing, and retrieving data when needed. While separating logic and data in two different layers made things better, it was still a centralized way to designing application, and it didn't address quite well the challenges associated with complex applications and systems. Let's take a look at these challenges. Application complexity has been exponentially growing with the advent of global high-growth festival wing web and mobile applications. Maintaining, evolving, and scaling very complex applications like Amazon e-commerce website or Google search engine required a design paradigm shift. Here again, the best way to tackle complexity is by decomposing it into manageable chunks. That is why software engineers decided to break apart the logic and data layers into smaller pieces called microservices. Every microservice deals with one business function end-to-end independently from other microservices. Microservices present simple, easy-to-understand APIs and communicate with each other through lightweight common protocols such as HTTP or message queues. When an application is architected as a microservices, different teams can work separately and independently on different microservices. Building new functions and evolving the business capabilities without impacting other teams and business functions. Theoretically, teams could even use different programming languages and deploy their microservices to different infrastructure. However, for cost reduction, efficiency improvement, and operational optimization reasons, most organizations limit team choices to a set of approved tools, infrastructure providers, and programming languages. As applications continue evolving and growing, the number of microservices inside an organization could expand to tens, hundreds, or even thousands. As this happens, complexity starts creeping again. For example, if a microservice instance fails in production, it could generate cascade of outages within other microservices. Since the architecture is highly distributed, it could become difficult to identify the root cause and fix it in a timely manner. The software engineering community has been creating and inventing new tools to tackle and contain the ever-growing complexity of highly distributed microservice-based systems. Some of the popular tools include containerization, that helps deploy microservices in minimalist self-contained runtimes such as Docker containers. Container orchestration systems that manage containers' life cycles such as Kubernetes pipeline. Automation for CI/CD. Asynchronous messaging that further the couples microservices by providing message brokers and queues, application performance monitoring tools to track microservice Performance login and audit tools that help keep track of everything happening within the system. We need to understand that microservices are not a magic bullet that fixes all application design and development problems. Applications are still designed as monolithic when they are relatively simple with limited number of users and not fast evolving. Remember that highly distributed systems are hard.